we are talking about the second term. We said JavaScript is a non-blocking language. So first we need to understand what is blocking. Let's say we have a JavaScript file where the first line we are calling HTTP module, and we are asking, give me the response for https://code.com/d1, and it gives you a huge content, probably a JSON data. It's a huge data, and but it's an IO operation. It is going to some other website or maybe an API server and fetching the data. So definitely it is going to go through a network, and it will take some time. It is going to take a little extra time. Then the second line is going to the second API or maybe a different website. The third one is going to the third API or the third website. These three, the first three lines are the network calls. It is going to happen over the network. So it is going to take little time, right? Because it has to create connection and then, do the handshake, then fetch the data, then close the connection, and all that will happen for each and every line. Finally, it actually do the console logging for all the three data, whatever it is. So we'll see how in general scenario, how does the thing happens. Your cursor goes to the first line and it is waiting. So your spinner is spinning. It's waiting for, let's say, 2 seconds. So your call stack will look like something like this. You're down at the 0th level is your main function call. And then on top of that, http.get/d1. After 2 seconds, it returns a response. And this http.get call from the call stack gets popped out. The execution line comes here. It again calls an HTTP, which is IO operation. It is going to take some time. Your http.get/d2 calls go on the stack. It tries to connect, get some data. It takes around, let's say, 1.5 seconds. Comes back. The execution line is on third API call. The call stack is empty again, apart from main method. It has nothing. It is again going to wait for, let's say, 3. This is the slowest of all the 3 operation. It is going to take 3 seconds. So the spinner is going to spin for a while and everything is frozen. You can't do anything else. Your system can't do anything else. So you have lost 3-second time. Then fetch the data successfully, let's say, and you have the data 3 with you also. Then finally, the call stack is, call to the third API is removed from the call stack. And finally, the console log to data 1 will come on the stack on top of main method. So it will log the data 1, pop out of the call stack. The cursor will come to console.log data 2. Again, it will log the data 2, then data 3, and then finally main method will also pop up because the main method is exit. And now your call stack is empty. So this kind of scenario is a blocking scenario, right? You saw that we are making consecutively 3 IO calls, and during those moments, we have seen a lot of frozen state where we can't do much or we can't do anything. So this is what we call blocking. How do we improvise this in JavaScript? Because JavaScript has only one call stack. It contains only one thread. So how can we improvise? How JavaScript improvise? How it becomes non-blocking? So if you ask me how it becomes non-blocking, we'll go further and we'll talk about asynchronous. So there's a concept called asynchronous in JavaScript, or I would say Node.js as well. And it is very, very important. Again, you need to understand this concept. This is a method, and I will not say method. This is a 3 line of code which I've written. The first line is console.log hi, and then I have called a set timeout. Set timeout is nothing but web API call. I pass the second line is set timeout, where there is a method call. We call it callback, and we want it to be called after 5 seconds, which is 5,000 milliseconds. And then finally, we have another console.log. It states Modi University. So no surprises. We have already discussed. First, it will come here. It will print hi. Then it will go here, set timeout. It will wait for 5 seconds. And then it will print Modi University first. Then your 5 seconds is still running, spinning somewhere. And then after 5 seconds, out of the box, this students pops up and prints to the console. I'm saying console.log. So hi. And then I'm saying set timeout. What does it takes? It takes a method and then the timeout. So I'm going to pass an arrow function, which does the console.log. It happens only after 5,000 milliseconds. And then finally console.log. It says Modi University. And then here it will say students. Okay, so let's run this node test.js. You can see hi Modi University, and there's a gap, and then out of the box the students comes up and get printed on the console. So we know this, we have already seen this. Anyway, we are going to talk about how this happens under the hood. So again, we are going to see the call stack. First, the main function goes to the call stack. Then the execution comes to the first line, which is console.hi, and then console.hi goes to the on top of the main method. Then it prints hi. The console.log comes out of the stack. It goes to set timeout method. The second line, the set timeout method goes here with the two arguments. One is the callback function, and then the second one is the 5000 millisecond. Then suddenly this goes away. We don't know right now where it goes away, but it goes away and sits somewhere else in the corner and wait for the 5 second to happen. Then again, another console.log happens, which prints Moody University. Then control comes to the main. Your set timeout function is still waiting in one of the corner. Then your main exit. Then it waits for a few moments. We saw that. And then out of the box, this console.log comes up and it prints students, and then exit. Your call stack is empty. This is what was happening. Now, when I say this set timeout was sitting in the corner, what corner that is, we are going to talk about. So we have already seen the call stack. We understand what call stack is. So now we are going to, and we have already understood there are a few web APIs from which are being provided by the browsers, like set timeout, like XHR request, and then there are DOM methods too. So those are implemented by the browser, which is going to be called upon by the JavaScript engine. Now we are going to talk about concurrency and the event loop. We are going to see what exactly the set timeout was doing, in the corner. What exactly was it doing? So we have introduced few more layer here. One is stack. Earlier we had this code and then stack. Now we have a web API, and then we have a task queue, and then the event loop. Please look very, very carefully. And if you have any question, please do let me know. Definitely we know console.log will go on top of main method on the stack. It will print hi. Then the set timeout with the callback function goes on the stack. Then since set timeout is a web API method, it goes to the web API layer and sits there and there is a timer. Web APIs actually start a ticker or a timer where it is going to throw the callback at some point of time, and that point of time is just after 5 seconds. The main method is still there. Our stack is still not empty. Then your console.log Moody University happens. It goes to the stack. It gets popped up and get printed Moody University. Your timer is still running. Your control comes to the main method. Your main exit, timer is still running because these three things happen in a flash while your timer is waiting for 5 seconds with the callback. Okay. As soon as the 5 second happens, this web API throws this callback method to the task queue. There could be multiple, callback methods, and it could be slowly thrown to the task queue. Okay? It's a queue where all the callback functions get queued up. Fortunately, it's a simple example, and we have only one callback queued. So it has been thrown to the task queue. Now there is an event loop. ध्यान से सुनना, what does event loop does? Event loop looks at the stack. वो बार बार पूछता है stack से, देखता है stack की तरफ, क्या है stack empty है. Right now it sees yes, it's empty. The stack is empty right now. Then it goes to the task queue. Do you have any callback in the queue? Do you have any callback method in the queue? Yes, task queue says yes, I do have. Then what does event loop does? It picks the callback function and throws to the stack. Then this event loop runs and throws the callback to the stack. The callback method is nothing but this one highlighted with the pinkish color. Then callback method calls. Inside that callback method, we have a console.log. The console log goes on top of stack. It prints students and then exit from the stack or pop out from the stack, and then the callback gets popped up. So this is how the entire thing happens in Just. I hope I was able to make you understand. If you have any question, please do let me know. So you have a stack, you have a web API layer, then you have a task queue, and then you have an event loop. Event loop का काम ये होता है कि वो जाके बार बार stack को देखता रहता है कि क्या स्टैक एम्प्टी हुआ है. जब भी उसको दिखता है कि अच्छा स्टैक एम्प्टी है, इट गोज टू द टास्क क्यू एंड सी इफ देयर आर एनी कॉल बैक. अगर यहाँ पे कोई कॉल बैक होता है तो इट थ्रोज टू द स्टैक सो दैट the callback get a chance to run. Now I have another example, same code, but instead of 5000 millisecond, I am going to wait for 0 millisecond. So first the main method will go to the stack definitely, and method sits at the 0th floor of the stack. Now what will happen?
Console.log hi will go to stack.
So let's see. Console.log hi happens. I think I missed one slide. Happens. It prints the hi popped out of the stack space. Then definitely the second line comes to the execution. What happens exactly here?
So it will go to event loop.
No, not even. Event loop is here. From stack, it will go to the web API. So web API is going to throw this, I mean, this stack is going to throw this callback to the web API, because set timeout is nothing but a web API. So it goes here, okay, and timer starts with a callback. Timer starts for runs for how much? 0 millisecond. Then what will happen? Your callback will be thrown to the task queue. अब इवेंट लूप का क्या काम होता है? इवेंट लूप देखता है क्या स्टैक खाली है अपना अभी.
सर जब तक ये इवेंट लूप में जाएगा तब तक नेक्स्ट स्टेटमेंट स्टैक में.
We have seen that the set timeout goes here, it runs the timer for 0 second, the callback then goes to the task queue. अभी event loop का क्या काम है ये मुझे बताओ.
It will check if the stack is empty.
Yeah, it will check if the stack is empty. Is the stack empty?
Yes sir.
No, there is a main method. It's not empty. You can see a box is here. Main method is here, right? It's not empty. So it can't pick the callback from the task queue and throw to the stack. Always remember, JavaScript is all about one thing at a time on stack, right? So the main function is still in the execution. So next, what will happen? This console dot. So since event loop is not able to throw the callback, the line of execution will come here, console.log. It goes here and then it prints Modi University and popped up. So until now we have seen hi and then Modi University. Then still there is a main method. So event loop is still check कि यार स्टैक खाली है क्या. नहीं है खाली. मेन मेथड अभी भी है. फिर क्या होता है? मेन मेथड भी निकल जाता है. पॉप इट गेट्स पॉप्ड अप फ्रॉम दिस स्टैक. अभी हमारा स्टैक खाली हो गया. इवेंट लूप चेक करता है स्टैक खाली है क्या. हाँ खाली है. देन इट थ्रोज द कॉल बैक मेथड एंड द एग्जीक्यूशन कम्स हियर टू द कॉल बैक मेथड. फिर इसके ऊपर console.log स्टूडेंट्स का कॉल जाएगा. ये console.log जाएगा, स्टूडेंट्स प्रिंट होगा, देन कॉल बैक विल आल्सो पॉप.
So in this session, what we have seen is how JavaScript follows the single-threaded event loop model with callback mechanism, how the single-threaded non-blocking IO model works in Node.js. We have also talked about call stack, web APIs, task queue, and event loop, and how do they help in running a program in non-blocking mode. Hope this session helps you a lot. Thank you for joining.